right. Can anybody tell me what the name of this function is based on Friday? Maybe we should start with degree. What degree is it? It's a third degree polynomial, and that's because the highest exponent is 30. So what do we call a third degree? All right. So this is kind of our topic moving forward. We're moving away from quadratics into higher degrees. So this is a polynomial, degree 3, we call it cubic. So I want you to answer in a complete sentence. The weight of a diamond with a diameter of 12 millimeters is approximately, what is it? It's 8.528. And then I'm going to use carats, just like how they have it written here. Carats. You guys have seen like 14K gold? We looked it up in a class. The K is used for gold, but not diamonds. So I'm just going to spell out carats. So you plug in 12 here. You do 12 to the third before you multiply it. 12 squared and then multiply it. 12 times this. And actually, you can put it all in your calculator at once with parentheses, right? Any questions here on plugging in and evaluating? All right, let's look at your homework done for Friday. So, you guys, there's a bell word quiz tomorrow. I used to do them unannounced, and it was just too much for some people. So, bell word quiz tomorrow. That'll be about 30 points. So, if you have all your bell works done, then that's like a little boost. So, if your grade went down after the test, it probably went down about 4% on average. Everyone's grade, which is pretty typical because, like, with assignments, you know, it's kind of doable to get 100% on assignments, but less likely to get 100% on a test. So averages will go down, but overall the test grades are really good. Pretty high average. So this is from Friday. It was page 311. So I'll pass the test out tomorrow so that you can see them and do correction.
Oh, we gotta do something different. Oh, okay. Right? Just add it up. And then the same thing. That's the example. Wait, what's the page? Yeah, that's the example page, right? That book is showing? No, we're not worried about that. What do you mean you're not worried about that? All we're doing is this. This we haven't gone to this. But this is 3.5. Yeah, 4.25. Oh. This right here? Shocking? Yeah. Add them up. They were doing. Kind of. Just a small extent.
A lot of people got this chip. Alrighty, let me show the answers for the last three. Alright, today's topics for adding, subtracting, and multiplying polynomials. All things that you have done before, but the problems today are just a little bit longer. The exponents are higher. Just a little bit more difficult. But it's a really important day leading in tomorrow, which is dividing polynomials, and nobody has done that yet. So I'm just going to look at this example for a moment. This is adding. It's on page 319. If we already did this last chapter, so when you add polynomials, there's two options. You can stack them up vertically and add down, and that's what we did with elimination. It's just with adding, you can stop here with this sum. You can also just leave it going sideways and combine like terms. And for most of the chapter, we're going to leave it sideways. But today, for the problems we do, I want to practice vertically because I think it's just good to practice it for a day. It helps you get your like terms lined up really well. So on the assignment, did everybody write the assignment down? I said I'm going to do the odds, and then you guys are going to go through and do the evens. So I'm going to jump right into the first question, number 5. I'm not giving you guys a lot of notes because, like I said, this is a topic you have done before. So this is adding. I see the plus sign in the middle. This is page 325. Yeah. Adding is really just combining like terms. One thing that I noticed here is that the problem isn't given in the right order. So Friday we practiced putting things in standard form, making sure your highest exponents first. So I'm noting that. And then another thing that I'm noting is it goes, we have a power of 6, a power of 5. There's no power of 4. There's no power of 3. And then there's a power of 2 and a 1. So I have the problem here. This is optional. For the exponents that are missing, sometimes it's helpful to put like a 0 placeholder. So since there wasn't an x to the 4th, I put 0x to the 4th. And there wasn't an x to the 3rd, I put 0x to the 3rd. And I lined it up. And so I'm going to put that second polynomial right underneath it. So that the exponents are lined up. I have a pretty big important note for you here. I think everybody should write this down. You can trust me. When you add or subtract, you don't change exponents. Because like I said, we're going to add and subtract and we're going to multiply. So in just a minute, we're going to do a problem when we multiply. When you multiply, you add exponents. So that gets pretty easy. So write this down. Add or subtract, don't change exponents. It's fine. So we only had one 6 power, so that stays. I'm just adding the coefficients, not changing exponents. Neither one had an x to the 4th. I'm not going to write it. -3 minus 6, -9. That's the sum. We stop there. Just a really long polynomial and another really long polynomial. Our next one that I'm going to do is number 9. It's subtracting, which isn't very different. It's not. It's not very different. I don't want to go too quick. Oh, wait a minute. So 9 is a whole different example of subtracting. Alright, if there's a subtraction sign, and we did this with complex numbers, I said distribute a -1. So I'm just saying that same thing here. With a minus sign, it's like you multiply everything here by -1. So I'm going to change all the signs, and then I'm just going to add down like I just did. So that's going to be negative 7x to the 5th. That's going to make it a positive 8x to the 4th minus 2x plus 11. So I put some zeros in. That's not mandatory, that's optional. I just like to keep everything in order. Those zeros have to stay organized. Add down with the coefficients, don't change exponents. Okay, ready for the next one? And our next one is multiplication. Actually, all the rest of them are multiplying. So I'm going down to 13. So this is where the big change comes into play, and if we're not like thinking about it, we'll make mistakes. So as soon as you start multiplying, you start adding exponents. When you multiply the same base of a variable, your exponents get added. So the only real notes I'm giving you here is when you add and subtract, you don't change exponents. but when you multiply, you do. It's really the only notes I'm giving you. Okay, so this is distribution. And 7 times 5 has always been 35. No big deal. X to the third times x squared. We're going to add that to make it x to the fifth. 7 times 3 has always been 21. Well, this is another little tip I have for you. This x didn't have an exponent with you, but there is an invisible one. So I like to write it to make sure I add it. So I have x to the third times x to the first. That's going to make x to the fourth. So sometimes when I don't write in the invisible one, I just leave it, x to the third, instead of adding it. So I put an invisible one in. And lastly, 7x to the third. You can, you don't have to. This one? Yeah, you can. Oh, no, it doesn't. You know what it does? I'll tell you. That one is like this. Because x to the 0 actually equals 1. So it's like gone. That's why there's just a 1 there. Like we call that a degree 0. Because it's x 1 0. That was a really interesting question. Very good. Yeah, I'm just adding the exponents on the variable. So those numbers I don't really care about. Exactly. Yep. Alright, so 17 is like a whole new ballgame. It's like so much distribution. It's similar to FOIL. Are you guys ready? I don't know. You ready? It's similar to FOIL, but it's a 3 by 3. So you're going to end up with 9 terms with a 3 by 3. If you're a student that has like multiple colored pens and you like to use all of them, this is a good chance to do it because I'll switch colors easy here. But so I'm going to cover up these two and I distribute the x squared 3 times. And then I change colors and I distribute the minus 2x to all 3. And then I change colors again and I distribute the minus 4 to all 3. And it just makes it kind of a more like substantial experience. Switching colors, I can see exactly what's happening. You don't have to. Yeah, right. All right. I probably would not have done it when I was a student, but sometimes you just rush too much and then you don't remember it. So first I'll do this x squared. X squared times x squared, x to the fourth. X squared times a minus 3x minus 3x to the third. So here's another situation where I'm going to write my 1 here. So I remember to add. I actually missed that one earlier today. X squared times minus 5. There's the first 3. Now I'm going to switch colors. Do the middle one. Now I'm focusing on that negative 2. There's the middle 3. I'm going to switch colors one more time and distribute the minus 4. Here we go. It's nice. 3, 3, 3. See, I distributed everything I needed to. With this many terms, I kind of like will go back and just, do a quick check sometimes. Sometimes I'll do these twice through. You're likely to make a little mistake. Alright, now we have to combine our terms. So start with your highest exponent. There's only one x to the fourth. And so I'm going to mark them off after I use them so that if I forget any, I'll see that it's not marked off. So I have 2x to the third powers to combine. Three x squared to combine. And there's the product. A lot of issues. And tomorrow we're going to divide. Right? The question is everybody ready to move on, or do we have a question? Ready to move on to 21. 21 is the most important problem in the assignment. So let's do it. Anybody want to take a picture? Want me to go back? So there's 3 binomials. You ignore the third one, FOIL the first 2, and then you multiply the third one in. The reason I said this one's the most important is because doesn't this look a lot like factors? This looks a lot like chapter 4, chapter 3, but there's an extra factor. Since there's 3 sets of parentheses, I know that this is a third degree polynomial. So instead of this being x squared, I can see these 3 multiplied. That's going to be an x to the third. So while today we're multiplying, most of the chapter, we're going to be trying to factor, trying to come up with these parentheses, okay? Let's go ahead and FOIL the first 2. So I ignore number 3, do my first, outer, inner, last, combine these like terms in the middle, and now I will bring in the number 3 I ignored. Pretty exciting, right, Sydney? Had that third one, and we didn't do it. Now we get to do it. I'm pumped. All right, so now I'm going to, okay, here we go. So I got to do x squared all the way to that x squared all the way over to the 4. Okay. So I'm going to talk about this one a little bit longer. So like you said, it's the polynomial, and most of the chapter is spent learning how to go from this standard form into these factors, and then from these factors into a graph. So I'm going to preview the graph for you. Just like with quadratics, you saw x-intercepts here. Like I would have an x-intercept at +3, so I would set it equal to 0, -2 and -4. I see that again here. So if I have those factors, I can do a rough sketch of the graph. An intercept at 3. Where's the other two intercepts, Maya? Looking at the original problem, what are the x-intercepts? -2 and -4. You know where we're coming up with that? You take them out and set them equal to 0. Not right now, but that's the whole point of the chapter. Okay, so look, I got an x-intercept at 3, at -2 and -4. And now I can draw this cubic function. I'm going to start low. I move through the intercepts. This is still a y-intercept. I go all the way down, and I come back up. And that is what a cubic function looks like. So because there's 3 x's, there's 3 intercepts, you don't just turn once, you turn twice. So this is the graph we're working towards. Let me move this thing.